Hi everyone. Today we're going to be looking at how to find absolute maxes and mins using the closed interval method. So the last couple days we've started talking about maximums and minimums and how to find them on a graph. And then we talked about yesterday how to find critical numbers and critical points. So we're going to be using critical points in order to find our absolute maximum and minimum values. So the key thing here is that we're looking for absolute maxes and mins. And we're going to be always looking on some interval from A to B. So our first step is going to be to find the critical points of the function in the interval. So that's where we take the derivative and set it equal to 0. And then what we want to do is we want to take the critical points and calculate the value of f of x at both the endpoints of the interval and the critical points. And then once we know those values, then we can pick out what the absolute maximum is, or the biggest value, and the absolute minimum, or the smallest value. So our first example is to find the absolute maximums and minimums of this cubic function on the interval from 0 to 6. So my step 1 is going to be to find my derivative. And in order to use the derivative, or we're going to use the derivative to find the critical numbers. So I'm going to take my f prime. That's going to give me 6x squared minus 30x plus 24. I'm going to set it equal to 0. And I'll go ahead and factor this. So I think we end up getting factors of x minus 4 and x minus 1. So that's going to give me critical numbers of positive 4 and positive 1 when I separate those out and set them equal to 0 using the zero product property. So here are my critical numbers. So once I know what the critical numbers are, then I need to make sure that these critical numbers of 1 and 4 actually fit in the interval that I'm looking on. So 1 and 4 are both in the interval from 0 to 6. So once I've determined that my critical numbers are in the interval, then step 2 is to calculate f of x at the endpoints of the interval and the critical points. So what I like doing here is I like setting up a t-chart to calculate what the f of x values are. So what I mean by that is I'm actually going to set up, it almost looks like a table of values here, where I'm going to have the x values on the left-hand side, and I'm going to have f of x values on the right-hand side. And the values that I'm going to put here in the left are going to be the endpoints of the interval. So I'm going to start with 0, and I'm going to end with 6, because that's my interval from 0 to 6. And then I want to put the critical numbers that I found in step 1 into here so that I can go ahead and calculate out what the f of x values are. So again, when I'm calculating f of x values, I'm going back up to the original function. So to do f of 0, again, you can use a calculator to help you with these values. I'm just going to do 2 times 0 cubed minus 15 times 0 squared plus 24 times 0, and then plus 7. That should just give me a 7 here. And then for the other values, I'm going to do the exact same thing. I'm just going to take 1 and I'm going to plug it into here, take 4, plug it into here, take 6, plug it into here. And again, if you want to use a calculator, that can definitely help you do this a little bit quicker. So I think 1 ends up being 18. Again, that's just f of 1, plugging that back up into that function up there. F of 4 is negative 9. And then f of 6 is 43. So these are my values of both the endpoints and the critical numbers. So step 3 is to say, okay, now that we've got all these values, I'm literally just going to be picking out the absolute maximum value by looking at what the biggest number is here. And then I'm going to pick out the absolute minimum value by looking at what the smallest number is here. So step 3 is to actually identify the absolute maxes and mins. So here, my absolute maximum is going to happen at the largest value. And that's going to be at this 43. And I'm going to write this using the notation that we talked about back on day one when we started talking about absolute maxes and mins. So I'm going to say my absolute maximum is f of the x value of 6 is equal to 43. And then my absolute minimum is going to happen at the smallest value, which is this -9 here. And again, I'm going to write it in that notation. F of the x value of 4 is going to be equal to -9. And that's my absolute maximum and absolute minimum of this function over the interval from 0 to 6. So here's my answer. All right, so we'll look at a couple of other examples. So we'll look at a rational function and we'll look at also a trig function. So we want to find the absolute extreme values. So remember that when we talked about on the first day, extreme values is just a different way of saying absolute maximums and minimums. So my step one is still going to look the same as it did in example one. I want to get the derivative of this. I am going to need to use the quotient rule. So I'm going to call my fx, my f prime 1. G is going to be x squared plus 5. And it looks like g prime is going to be 2x. So I'm going to go ahead and set up my quotient rule here. So I'm looking for my critical numbers first. So f prime times g is just going to be x squared plus 5 minus f times g prime is going to be x times 2x all over g squared, so x squared plus 5 squared. I'm going to go ahead and simplify my numerator. So it's going to be x squared plus 5 and then minus x times 2x is 2x squared. All over x plus 5 squared, or x squared plus 5 squared. And then my derivative here is going to be, looks like negative x squared plus 5 over x squared plus 5 squared. So here's my derivative. So then I need to find my critical numbers. And remember that with a rational function, critical numbers could come from both the top or the bottom. So I'll start with my numerator. So I'll do my negative x squared plus 5 equal to 0. That's going to give me negative x squared is equal to negative 5. Divide everything by -1. X squared is equal to 5. And then x is going to be equal to plus or minus the square root of 5. Because don't forget that we do need to make sure that we're getting both values when we take that square root. From the denominator, I'm going to take this quantity, so this x squared plus 5 squared, set it equal to 0. Take my square root to get rid of that power of 2. That's going to give me x squared plus 5 is equal to 0. Subtract 5, that's going to give me x squared is equal to -5. And then for this one, there's kind of a problem here because when I take the square root of this, this is going to give me x is equal to plus or minus the square root of -5. This is an imaginary number. So this denominator actually does not produce any critical numbers. So if I get an imaginary number here, this is not a critical number. So that would mean that my only possible critical numbers here would be plus or minus the square root of 5. But remember that we have to check to make sure that they're actually in the interval. So if I type this into my calculator and I want to know what the square root of 5 is approximately equal to, it's about 2.23. And then if I type in the negative square root of 5, it's about negative 2.23. So if I look at the interval that I'm working on the interval from 4 to 8. So neither of these values are actually in that interval from 4 to 8. So in this case, we actually don't end up getting any critical numbers from our derivative. So technically, yes, these are critical numbers, but they do not fit in the interval. So yes, I do have critical numbers there, but they do not fit in the interval from 4 to 8. So these actually are not used in our step 3 or step 2 to actually go back into our original function and test the values. So my step 2 here is going to look a little bit different. When I go to set up my t-chart, I'm still going to do the x and the f of x values, but I'm going to start with my 4. I'm going to end with my 8. But because none of these values fit in the interval, I actually don't have anything to put in here. So when I'm going to actually do my f of x work, the only ones that I have to worry about are these two, because I don't have critical numbers that fit in that interval. So I'm going to go ahead and I'm going to do f of 4. And again, I'm going to plug those back up into the original function. So that's going to give me 4 over 4 squared plus 5, which is 4 over 16 plus 5, or 4 over 21. And then I'm going to do the same thing with the f of 8. So that's 8 over 8 squared plus 5. So 8 over 64 plus 5, or 8 over 69. So then of these two, we just need to determine which one's bigger and which one's smaller, because we need to determine which one's the absolute max and which one's the absolute min. So if you want to type these into your calculator to get a decimal approximation for like what 4 over 21 is, it's approximately 0.19. And then if I do the same thing for 8 over 69, that's about 0.16. So it looks like this one is actually larger and this one is actually smaller. So that means that my absolute maximum here is going to be f of 4 is equal to 4 over 21. And I'm just going to write that as an exact value when I write my answer. And then my absolute minimum is going to be f of 8 is equal to, again, I'm going to write this as 8 over 69 as an exact value. Okay, so we'll do one more example with a trig function. So I want to find the absolute maximum and minimum values of the function f of x equal to the square root of 3 times cosine of x plus sine of x, and we're looking on the interval from 0 to pi over 2. So first step, get the derivative of this to find my critical numbers. So this is going to be root 3 times the derivative of cosine, so negative sine. So it's going to be negative root 3 times sine of x. And then the derivative of sine of x is going to be cosine of x. And then I'm going to go ahead and set this equal to 0. Okay, so in this case, this is a little bit different than the ones that we've talked about in class so far because I have both a sine and a cosine here. What I'm actually going to do here is I'm actually going to try to collect all of my trig terms on one side of the equation by themselves. So what I'm going to do is I'm actually going to go ahead and subtract cosine from each side. And then, since I want to get all trig terms on one side of the equation, I want to bring the sine over as well. But in order to do that, I'm going to have to divide it out. So that's going to give me negative cosine over sine. So because I know that this is a quotient identity, I'm actually going to go ahead and turn that into a cotangent. Because remember that cotangent is really cosine over sine, but since it's negative, this is going to end up being negative cotangent of x. And then over here, I'm left with a negative root 3. And then I want to get rid of the negative on this term, so I'm going to go ahead and divide everything by negative 1. So I end up with something that says cotangent of x is equal to root 3. So what I need to do is I need to take the inverse cotangent of root 3. And remember that this is asking me, as soon as I do an inverse function, this is asking me which angles or angle on the unit circle have a cotangent of root 3. And remember that cotangent is the same thing as x over y, because cotangent's ratio is x over y. So if I look in the first quadrant of my unit circle and I'm trying to determine which angles have a cotangent or an x over y of √3, well, we could play around with some numbers if we wanted to, just to kind of determine which one of these is going to work. It obviously wouldn't be 0 or pi over 2. It's got to be kind of one of these in the middle here. It's not going to be the pi over 4 because that cotangent is just 1. So it's got to be pi over 6 or pi over 3. So if I play around with a little bit of numbers here, so if I do my ordered pair for pi over 6, and I want to test to see what is x divided by y, well, my x here is √3 over 2. When I divide that by my y of 1/2 and do my keep change flip here, √3 over 2 times 2 over 1, my 2's end up canceling out, and there's my cotangent of √3. So that means that my angle that I'm looking for in the first quadrant is going to be pi over 6. And I only have to worry about this one critical number here, because if I go back up and I look at the interval that I'm working on, I'm only working on the interval from 0 to pi over 2. And since pi over 2 is right here, I only have to worry about this first quadrant value here. So that's going to be the only value in that interval that's going to have a cotangent of √3. So here's my critical number. Now what I need to do is I need to set up my t-chart. I'm going to put in my endpoints, so 0 on the top, pi over 2 on the bottom, and then I'm going to put in my pi over 6 right in between. So my critical numbers are 0, pi over 6, and pi over 2 that I'm looking to test, and then I can just go ahead and actually do my math by plugging it back up into this original function. So this one is going to be √3 times cosine of 0 plus sine of 0. And I know that cosine of 0 is just 1 and sine of 0 is just 0. So this actually just ends up being a square root of 3. For pi over 6, I'm going to do √3 times cosine of pi over 6 plus sine of pi over 6. And cosine of pi over 6 is √3 over 2. Sine of pi over 6 is 1/2. So when I multiply √3 times √3, that just leaves me with 3/2 plus 1/2. And that's going to give me 4/2, which is just 2. And then if I do the same thing for my last value here, √3 times cosine of pi over 2 plus sine of pi over 2. Cosine of pi over 2 is just 0, so this is just √3 times 0. Sine of pi over 2 is 1, so this just ends up being a 1. So what I'm looking for of these values, again, is just what's the biggest one and what's the smallest one. The square root of 3 is 1 point something, so it looks like my biggest value is the 2. It looks like my smallest value is the 1. So that means that my absolute max here is going to be f of pi over 6 is equal to 2. Looks like my absolute min is going to be pi over 2. So f of pi over 2 is equal to 1. And those are my absolute maximums and minimums. So I'm going to have you guys work on some practice and let me know if you have questions.